Radians are units for measuring angles. But before we get started, let's see if you remember how to measure angles using degrees. How many degrees are in this angle here? To review how to measure angles in degrees instead, click down here. Great, so you know about measuring angles in degrees. We'll get to what radians are in just a moment. But first, let's say you have a circle, and let's call the radius of the circle r. What's the circumference of this circle in terms of r? If you're not sure, click down here to review. Right, the circumference of a circle equals 2 times pi times the radius. Let's just hold on to this fact up here. Next, let's make a circular arc that has the same length as this circle's radius. So let's make a copy of the circle's radius. And now let's bend it so it has the same length r, but it's now an arc along the circle. Let's label the angle that this arc makes with the center of the circle. This angle is defined as being exactly 1 radian. So 1 radian is an angle whose circular arc has the same length as the radius. Take a close look at this angle. About how many degrees would you say are equal to 1 radian? That was a really good estimate. Now let's try to find the exact answer. We'll start by figuring out how many radians make up a 360-degree angle, like this one at the center of the circle. Let's keep track of different angles measured in radians and the lengths of their corresponding arcs. We said this angle is 1 radian, and an angle of 1 radian has an arc whose length equals r, the radius of the circle. Now an angle of 2 radians has a total length of r plus another r, or 2r. An angle of 3 radians has an arc of 3r. 4 radians has an arc length of 4r. Here's 5 radians with an arc length of 5r, and we have room for at least one more radian. So here are 6 radians with an arc length of 6r. At this point, you're probably noticing a pattern in this table. To find an angle's arc length, you can multiply the angle by the radius. So for example, an angle of 4 radians has an arc length of 4r. Now it looks like 360 degrees is equal to about 1, 2, 3, 4, 5, 6, so maybe 6.2 or 6.3 radians. But what's the exact number of radians that equals 360 degrees? Well, 360 degrees is the angle whose arc is the entire circumference of the circle. And you already said that length is equal to 2 pi r. So using the pattern in this table, try figuring out how many radians are equal to 360 degrees. That is, the number of radians whose arc length is 2 pi r. And by the way, there should be a pi somewhere in your answer. Exactly, 2 pi radians have an arc length of 2 pi r. And that means that 2 pi radians equals 360 degrees. Another way to think of 2 pi radians is 2 pi times 1 radian. So how many degrees are in exactly 1 radian? In other words, try solving for the 1 radian in this equation, and that will tell you precisely how many degrees are in this 1 radian angle over here. Again, there should be a pi somewhere in your answer. Exactly. You can solve for the measure of 1 radian by dividing both sides of this equation by 2 pi. So 1 radian equals 360 degrees divided by 2 pi. 360 degrees is also equal to 2 times 180 degrees, so let's rewrite it like that. And now notice that we have a 2 in the numerator and another 2 in the denominator, so they cancel out, leaving us with 180 degrees over pi. So 1 radian equals exactly 180 degrees divided by pi, which is about 57.3 degrees. That's pretty close to your estimate from before. You'll often see radians written in multiples of pi. So as we said, a full 360-degree rotation is 2 pi radians. A half rotation, which is 180 degrees, is half of 2 pi radians, which is pi radians. How many radians are equal to a right angle? That is, a 90-degree rotation. Your answer should have a pi in it somewhere. Now in this interactive, you can see how different angles are measured in radians. Try rotating these two red lines by dragging the arrowheads. The angle between the lines is shown in yellow, and the exact size of the angle, measured in radians, is shown up here. Try playing around with these lines to make a few different angles, and when you're ready, try making an angle that's approximately 4 pi over 3 radians. Nicely done. Try one last problem. Make an angle that's approximately pi over 4 radians. The two units that are commonly used to measure angles are degrees and radians. Here, we'll find a way to convert angles back and forth between these two units. Let's look at degrees first. How many degrees are in a straight angle, like this angle here? If you'd like to review how to measure angles in degrees instead, then click down here. Exactly, a straight angle is 180 degrees. And how many radians are in a straight angle? If you'd like to review radians, click down here. Nicely done. A straight angle equals pi radians. By the way, a shorter way to write radians is to just write it as rad. So pi radians and 180 degrees are both the measure of a straight angle. In other words, pi radians equals 180 degrees. Let's look at another example of two quantities that mean the same thing. 24 hours is a length of time, and so is 1 day. These are two equivalent amounts of time that are equal but have different units, hours on the left and days on the right. Let's divide 24 hours by 1 day to make a fraction. What does this fraction equal? Well, since 1 day equals 24 hours, we can substitute 24 hours for the 1 day in the denominator. And now we have 24 hours in the numerator and the denominator, which cancel, leaving us with 1. So 24 hours divided by 1 day equals 1. This shouldn't be too surprising. Whenever you divide something that's not 0 by itself, you get 1. And 24 hours and 1 day are indeed the same thing. They're just two different ways to say it. And just as 24 hours divided by 1 day equals 1, 1 day divided by 24 hours also equals 1. Similarly, pi radians and 180 degrees are two ways of describing the same angle. So evaluate these two fractions. Pi radians over 180 degrees and 180 degrees over pi radians. Very well done. Both of these fractions equal 1 because pi radians equals 180 degrees. These two fractions are the keys to converting angles between degrees and radians. Let's see an example. Suppose we want to know how many radians are equal to 270 degrees. Well, 270 degrees is certainly equal to 270 degrees times 1. And 1 happens to equal this fraction up here, which has degrees in its denominator. So let's replace the 1 with this fraction. 270 degrees equals 270 degrees times pi radians over 180 degrees. But if we move this denominator over here, we can simplify this expression. 270 degrees equals 3 times 90 degrees, while 180 degrees equals 2 times 90 degrees. The 90 degrees in the numerator and denominator cancel, which leaves us with 3 pi over 2 radians. And that's our answer. 270 degrees equals 3 pi over 2 radians. Try another example. How many radians equals 60 degrees? Multiply 60 degrees by this fraction and simplify to get an expression that's in radians. Right, when you multiply 60 degrees by pi radians over 180 degrees, you get pi over 3 radians. Now let's try an example where you have an angle measured in radians, like 2 pi radians, and you want to convert this angle into degrees. So let's start with 2 pi radians. 2 pi radians equals 2 pi radians times 1. And now let's replace the 1 with this fraction, because this one has radians in the denominator. And now we're dividing 2 pi radians by pi radians. The pi radians cancel, leaving us with 2 times 180 degrees, which equals 360 degrees. And so multiplying our angle in radians by this fraction gave us the angle in degrees. Try another example of converting from radians to degrees. How many degrees equal pi over 4 radians? Great job! You multiplied pi over 4 radians by 180 degrees over pi radians. The pi radians cancel, leaving you with 180 degrees over 4, which equals 45 degrees. So to summarize, if you have an angle in degrees, you can multiply it by pi radians over 180 degrees. This will convert your angle into radians, because the degrees in this denominator will cancel out with the degrees of your angle. Similarly, if you have an angle in radians, you can multiply it by 180 degrees over pi radians. This will convert your angle into degrees because the radians in this denominator will cancel out with the radians of your angle.